Welcome to a screencast for Pythagorean Theorem Challenge. Before we work with the Pythagorean Theorem Challenge, you need to be comfortable in working with basic Pythagorean theorem problems. We'll use a lesson like this in the future when we deal with right triangle word problems. Our goal for this lesson is to be able to use the Pythagorean theorem in an applied setting. Let's take a look at our first example. Although you can read, please follow along. The Pythagorean theorem is used extensively in carpentry and construction. Consider the 3, 4, 5 rule of a right triangle. It is the best way to square two walls. If you measure one wall out to 3 feet and the other wall out to 4 feet, then the hypotenuse should be 5 feet. So basically what it does is after you build, many carpenters measure to 3 feet, measure out to 4 feet, and then check the hypotenuse. If it turns out that they have a triangle with sides 3, 4, and 5, they know they have successfully created a right angle. And that's pretty important when you're thinking about building a house or anything else that's going to have to stand up over time. So if you wanted to square something larger, then you could use another rule. So instead of using a 3, 4, 5 rule, there are other rules that you could use. So what we're going to do is see which of these two rules could a carpenter use. So let's take a look at the 5, 12, 13 rule. And what I'm going to do is use the Pythagorean theorem. And what I'm going to do actually is just test to see, does 5, 12, 13 create a true Pythagorean theorem statement? So the first thing I do is I personally use a t-chart whenever I'm checking something. So I'll put my a squared plus b squared on the left, and I'll put my c squared on the right. And I'm just going to fill in the blanks, keeping in mind that your largest number should be the hypotenuse. Your largest number should be your c squared. So when we substitute 5 for A and 12 for B and 13 for C, we're checking, does 5 squared plus 12 squared equal 13 squared? So 5 squared plus 12 squared is 169. 13 squared is also 169. So 5, 12, 13 is a success. It makes the Pythagorean theorem true. Now let's check for 16, 63, and 66. I'm going to do the same basic process, set up my t-chart, plug my numbers in, making sure that my 66 is my C. So does 16 squared plus 63 squared equal 66 squared? And it turns out that we do not have a balance. These are not equal to each other. So 16, 63, 66 is not a rule that a carpenter can use to check to see if there's a right angle. So that's one of the types of problems that we might see. Another type of problem, let's just take a look. Taylor started her walk by walking 6 miles due east. Then she walked 7 miles north, 10 kilometers east, and finally 5 kilometers to her final destination. Well, if she took the direct route back, how many kilometers would she have to walk? So we're looking for the length of that blue segment. So what we're going to do whenever we're dealing with distances, it's kind of nice to be able to use the Pythagorean theorem. So what I'm going to try and do is see if I can imagine one giant right triangle instead of 2 little ones, because that I really don't know what point that is, or I don't know what point that is. So what I'm going to do is just drop and extend some of our lines to get to this right triangle. So I'm going to be looking for the blue line, but how long is this little segment here? Well, if she went 6 kilometers east and then another 10 kilometers east. In total, she was 16 kilometers east. And if she went 7 kilometers north and another 5 kilometers north, that would be 12 kilometers north altogether. So I'm just going to use the Pythagorean theorem using 16 and 12, and I'm going to solve for the hypotenuse. So I'll substitute my values, simplify, combine my like terms, and then to solve, we would take the square root of both sides. So the square root of 400 would be plus or minus 20, and the square root of c squared is c. Now, because this is a real-world situation, I'm not going to consider the negative 20. You can't walk negative 20 kilometers, so my final answer would be positive 20. So in total, Taylor would have to walk 20 kilometers. So that is an example of how you would use the Pythagorean theorem in an applied setting.